Hello, welcome to another video with Mathemasoft. In the previous videos, I've explained what quadratic equation is all about, and we have looked at quadratic equation as any equation that can be written in the form ax squared plus bx plus c equals to 0. We also enlisted the approaches or methods that you can use in solving problems relating with quadratic equations. We said that you can use 4 basic methods. The first one being factorization, next completing the square method, followed by quadratic formula, and then the graphical method or graphical analysis. In the previous 2 videos, we have looked at how to solve quadratic equation using factorization method. And I want to say a big congratulations to those students who have checked up on those 2 videos and haven't mastered the approach of solving quadratic equation using factorization method. In that class, I gave you 2 questions for you to practice with, and those 2 questions, I'm still expecting your response in the comment section to know the answers that you arrived at, and for me to know that those answers are actually correct, or I may have to do a video solving the 2 questions I gave you as the exercises. So in this video today, we want to begin with studying completing the square method as one of the approaches of solving quadratic equation. Completing the square method is a very simple and straightforward method of solving quadratic equation. But if you handle it carelessly, you may make it to appear complex. Now, before we begin to solve the questions we have on the board using the method completing the square method, let us first lay some foundation of things that you may come across while solving quadratic equation using completing the square method. They are just basic knowledge that you should have in mathematics. For example, if I'm to expand x plus 2 over 3 squared. If I'm to expand x plus 2 over 3 squared, then I can say this equals x plus 2 over 3 bracket x plus 2 over 3. So expanding this, I want to first use x to expand everything such that I will have x bracket x plus 2 over 3 multiplying x multiplying all this, then plus 2 over 3 multiplying all this. Okay, this is how we expand in mathematics, and I do hope that you have that foundation. But even if you do not have the foundation, this will actually help you. So x multiplied by x will give me x squared plus x times 2 over 3 will give me 2 over 3x plus 2 over 3 times x will give me 2x over 3, and then plus 2 over 3 times 2 over 3. Rather than using these as a direct multiplication, since it's 2 over 3 times 2 over 3, both of them are the same, I can just write it as 2 over 3 squared. Okay, instead of doing 2 times 2, 4, 3 times 3, 9. So I can write it as well. 2 over 3 times 2 over 3 will give me 2 over 3 squared. So this is what I will have. So I have 2 terms, okay, in x. So I can sum them up or I can combine them. So this will give me x squared plus, okay, this will give me LCM of these two will give me 3. And then I'm going to have 2x, because 3 here will give me 1 times 2x, and then I'm going to have 2x. That will be plus 2 over 3 squared. And x squared plus 2x plus 2x will give me 4x over 3, okay, plus 2 over 3 squared. Now, what we have done now is to just what? That we expanded this, and then it gave us this. I want us to lay emphasis on this. That this expression in mathematics can be written like this. And this expression in mathematics can also be written like this. How can we write this straight up? Having this, how can we write it directly like this? We can write it directly like this by studying this. X squared plus 4 over 3x plus 2 over 3, okay, squared. If I want to write it like this directly, I only pick this x and what I have inside the bracket here, which is what? Plus 2 over 3, and then I put it all square. So you can see this. I've been able to what? Write this. Can you see? Looking at this, I can what? Write this. Looking at this, I can what? Write this. That is x plus 2 over 3 all squared. If you expand this, it will give you this back. Okay? If you expand this, it will give you this back. That's what we did. We expanded it and it gave us this. So this is the knowledge you must have in completing the square method. In completing the square method, we are not going to show this, okay, but we will be given, okay, we are not going to show that what this, all we need to show rather is that what this can be like this and this can be like this, but all these things that I solve in between will be found missing, so you will not see it, and that is why some students normally get confused. All this explanation that I did here will not appear from here to here, will not appear. All you will just see is that you have an expression like this and it's being written like this. So you should know when you have this, you should learn how to write it like this. When you have this, it will be x plus whatever you have inside this word place in this constant, then all square. So that is the skill that you should have fundamentally if you must use completing the square method correctly. Okay, let us also try to look at some other what expression here. Okay, I can also say that x minus 1 over 3 squared. Let us try this also. So this will give me x minus 1 over 3, okay, bracket x minus 1 over 3. And that will give me x times x, x squared, x times this minus 1 over 3x, minus 1 over 3 times x minus 1 over 3x again, and then minus 1 over 3 times minus 1 over 3 will give me plus minus 1 over 3 squared. Okay, that's if I do not want to multiply directly. So I can say minus 1 over 3 times minus 1 over 3, that is twice. If you say minus 2 times minus 2, the answer is minus 2 raised to power 2. That's what it means. So if I have minus 1 over 3 times minus 1 over 3, okay, the answer to this is minus 1 over 3 what? Squared. That's if I don't want to do minus times minus, 1 times 1, 3 times 3. So I can express it like this. So we are expressing it like this because that is how you can understand, you know, when you are using completing the square method. So I can now combine this term in x by saying that what 3 is the LCM, okay, so that will give me 3 here, okay, 1 times this 1 that is up here, that will just give me x. So I don't have to have what 1x, I can just write what x. Then I have another minus here, so 3 here will give me 1 times this what 1 and x, that will also give me what x. So I can say plus bracket minus 1 over 3 squared. Okay, so writing this now will give me x squared minus x. There's minus here, there's minus here. So when you're adding this, it's going to be minus x minus x. That will be minus 2x over 3, okay, plus bracket minus 1 over 3 squared. So in other words, what we are saying here now is that this can be written like this. So let us use this one now to get this directly. So it's going to be x, which is here. What do we have inside bracket here? Minus 1 over 3, okay, squared. So that means that what directly from here we can write this, okay, and when we expand this, we can get this. directly from here, I can write this, because when I expand this, it is this. Indirectly, this is equal to this, and this is equal to this. That's what we are saying. So, in completing the square method, we will have this form to be written directly as this. We will have this form to be written directly like this. So, you have to understand this foundation so that when we get to that step where we have something like this, to write it directly like this will not get you confused. When we have something like this, writing it directly like this will not get you confused. Just pick the x. You can see this is in square, this is in square. This is in square, this is in square. Just pick x and pick what is what. Also inside this, with its own sign. Because the sign here is plus, that's why it's plus 2 over 3. Because the sign here is minus, that's why it's minus 1 over 3. And then both of them are squared. When you expand this, it's the same thing as this. When you expand this, is this. So it is very important, and it is a fundamental knowledge to understanding completing the square method, solving quadratic equations. So now that we understand this foundation, okay, let's get started with the questions that we have on the board. Now, a careful observation of the questions on the board would actually remind you that these are the questions, same questions that we used while solving quadratic equation using factorization method. So I know that you must be familiar with the answers that we got while we use factorization method. And that is what you must note, that irrespective of any approaches you use, out of the 4 enlisted approaches that we can use on quadratic equation, either factorization, either completing the square method, either quadratic formula or graphical analysis, your answer will always be the same. So if I use factorization to solve this question, if it can be factorized, because you must note that not all quadratic equations can be factorized. So if I use factorization method to solve this question, the answer that I may get must be the same when I use completing the square method. So we will use completing the square method now, but I hope you still understand, or you may still be familiar with the answers that we got while we use factorization method. Or you can actually use factorization method, to just practice with factorization method while you look at how I solve using completing the square method. And you will see when you compare the answers, they must be the same. So let's get started with completing the square method. So number 1, 2x squared plus 5x minus 12 equal 0. Now, what are the conditions with using the completing the square method? Number 1, your term in square, okay, must have the coefficient, okay, of 1. In other words, we are saying that what the term that appear in what in square, okay, must have what the coefficient of 1. So it means that what our a, that is your a, must always be equal to what 1. So for you to solve using completing the square method, you should try as much as possible that your a is equals to 1. So when they give you in a situation like this, because you can see that our a here is actually what 2 and not 1. You can see if I have ax squared plus bx plus c equals to 0, my a here is 2, it is not 1. So we have to find a way of making that a to be 1 before we proceed. So that's the first thing. So let's make a 1. So the number that we have as a here is 2. And how can we make 2 in this situation to be 1? We can only make it to be 1 by dividing it by 2. So 2 divided by 2 will give me 1. So, and in mathematics, you know that what is done to this side must be done to what? To the rest of the side. So here I will say I'm dividing all through by 2 because of these 2 and I want to make 1. And I'm dividing all through by what? 2 in both sides. So this will be 2x squared over 2, okay, plus 5x over 2 minus 12 over 2 even this 0 over 2. So 2 divided by 2 will give me x squared plus 5 over 2x minus 6 equals what? 0. And then let me make my constant to actually move to the other side. So I can say I have x squared plus 5 over 2x equals to what? 0. Equals to 6 rather. Pardon me. So I have x squared plus 5 over 2x equals 6. Now that I've gotten rid of my what? Constant being on the other side. And what? My a here is already 1. So these are satisfied the what? The condition. And what? This 6, which is the constant, has actually what? Left this side and moved to the other side. The next thing to deal with is for me to deal with the coefficient of this what? X. Because I'm already done with what? X squared. So I want to deal with the coefficient of what? X. Okay. In dealing with coefficient of x, so we say that the coefficient, okay, in the power of 1, okay, is then multiplied by 1 over 2, then squared, it is squared, and the results added to both sides. Anyway, I always try to avoid writing notes while solving mathematics for students, but I'm just putting this here in case it might actually what? Help you. But just follow my explanation. What we are saying is that the coefficient that is what? In the power of 1. So the coefficient x raised to the power of 1, okay? Because this is ordinary x. So the coefficient in, I would have written it as the coefficient in x. But sometimes your quadratic equation unknown can be a, can be b, can be x, can be y. So I don't want to just make it was static that way. It must always be in x. But what we are saying is that what? The linear, okay, the coefficient of the linear term in this particular what expression, we will take the coefficient. The coefficient means the number behind it. We will multiply it by half. Okay, that's what I mean by the coefficient in the power of 1. That's this x is raised to the power of 1. The coefficient in the power of 1 is then multiplied by half. Okay, is multiplied by half, then squared. It is squared what? And the result added to what? Both sides. So we add this to both sides. So that is what we mean. So what will this actually what result to? This will result to 1 times 5. It will give me 5 over 2 times 2. That is 4. So it means that what? We are to add 5 over 4 squared to both sides. Okay? We are to add 5 over 4 squared to both sides. And that's exactly what we are going to do now. So both sides means this side and this side. So I have x squared plus 5 over 2x. I'm adding this to this side plus 5 over 4 squared equals, this side has 6 already. So I'm now adding this one. That is 5 over 4 squared. Okay, so this is what I will have. Now recall, okay, all the analysis that I have to do have been done. So now it's time for you to remember, having this form now, okay? So this form now can be written, what I started with, as what? X plus 5 over 4 squared, okay, equals 6 plus 5 squared will give me 25, and 4 squared will give me what? 16. So you recall that I've already explained that this form can be written in this what? In this form. So that's what you need to remember this time now. So that's x plus 5 over 4 squared. If you want to try it out, if you expand this, just like I did in the introduction, if you expand this, it must give you what? This. So this and this, they are the same. We just cannot use it in this form, so we have to transfer it to this what? Form. And then I can say I have what? X plus 5 over 4 squared equals 6 over 1 plus 25 over 16. X plus 5 over 4, okay, squared equals 16. That's 16. 16 times 6, give me 36. Remember 3, 9 plus 25. Okay, and that will give me x plus 5, okay, over 4 now, squared again, equals 96 plus this, that's 101, that's 121 over 16. Okay, so I can now say I have x plus 5 over 4, taking the root of both sides. So that will give me plus or minus root 121 over 16. So that will be x equals plus 5 over 4, we move to this side, that's minus 5 over 4. What do I have here? Plus or minus. What is the square root of 121? 11. Square root of 16 will give me 4. So, and then x equals minus 5 plus or minus 11 over 4. And this will give me x equals minus 5 plus 11 over 4, or minus 5 minus 11 over 4. And this will give me x minus 5 plus 11 will give me 6 over 4, or minus 5 minus 11 will give me minus 16 over 4. So my x, therefore, will be equals to 3 over 2, or minus 4. So if you recall, when we solved this number 1 using factorization method, this is exactly what we got also, 3 over 2 or minus 4. Or you can say minus 4 or 3 over 2 in any order. So that is our what? Answer. So take it slow and take it calm. Completing the square method is straightforward. If you can understand this is the area of confusion. So let me break down again. Make your a to be 1 by dividing all through by whatever you have as a. So then I arrive at this. Let your constant go to the other side, that is 6. Multiply the coefficients of what? Ordinary x, or the one that is carrying what? Power of 1. Multiply the coefficient by half, square it, and add it to what? Both sides. That's all. So once you add it to both sides, everything is already solved. It's just for you to write this one in this form, and then you will find the LCM until you get to this. Take the square root of both sides, so that this square can be removed. Roots on top of this replace, will remove this square. So root will be here. Okay, and then you have that. Okay, let's solve question number 3. Okay, let me do question number 3 with you. Okay, I have reason for that, so that you can also attempt some questions on your own. Okay, let's solve question number 3. Now, question number 3 that I want to solve is one of the questions, 2 questions I gave you under factorization to try out on your own. So I'm going to use completing the square method to do it now. So you can compare my answer with the answer you got when you did your own in factorization. You must have done that, because it's one of the questions I gave you. That's why I actually selected it, so that I can actually do it, using completing the square method. So I have question number 3, that's x squared minus 6x plus 9 equals 0. Now, when you observe this question, you will see that what? My ax squared plus bx plus c is already satisfied, and my a in this case is already 1. So the first condition I listed for you is already fulfilled. You don't need to bother yourself. So my a is already 1. So I don't need to divide all through by anything, because a is already 1. So it's good to go using completing the square method. So now, the only thing for me is to move my constant to this side, which will make this one to be minus 9. So the coefficient of x here is minus 6. Please don't make mistake with this. Go with the sign. The coefficient I have here is minus 6. is not plus 6. So write out minus 6. Then you multiply it by half and then you square it. This is what you are going to add to both sides. So let's see what this will give us. What this will give us is that if I'm to solve it, it's going to give me 2 here 1, 2 here 3. Okay, if you put this one over 1 so that it will look like minus 6 over 1. So that will be minus 3 times 1. That will be minus 3 over 1 times 1 will give me 1. Okay, and the answer will be minus 3. So that will be minus 3. Let me write it this way. What this place will result to will be minus 3 over 1 squared. So which is eventually what? Minus 3 squared. So that's what we are going to have. So eventually it is minus 3 squared that we are adding to both sides. So let's do that. Let's continue solving. That will be x squared minus 6 now, plus you are adding minus 3 squared to this side, minus 9 on the other side. You are also adding minus 3 squared. This is straightforward. So just like the same way that I told you, look at this form. Okay, so it can be written as what? X, what do you have inside bracket here? Minus 3 squared will now give me minus 9 plus, what is minus 3 squared? Minus 3 squared means minus 3 times minus 3. Minus times minus will give me plus. 3 times 3, 9. So that will give me plus 9. Okay, so I now have x minus 3 squared equals minus 9 plus 9. That will give me 0. And then x minus 3 will give me root what? 0. What is the square root of what? 0. That's plus or minus. Don't forget that. Okay, because I'm taking the square root of both sides. So that is why I have what? Plus or minus what? 0. And then x equals to minus 3 to this side will give me 3 plus or minus. What is this what? Root 0. Root 0 will give me what? 0. That's x equals 3 plus 0 or 3 minus 0. X equals to 3 or 3. So, like I explained in the introduction, we can see that what? Although we have x having what? Two roots, two solutions, but the two roots are the same. So, instead of writing x equals to 3 or 3, so that it will not seem like what? Tautology, like the grammarian or the people in the use of English will say. So instead of writing 3 or 3, I can say x equals to 3, but what? Indicate that what? This is twice. So that I will not just be saying x equals to 3 or 3. That will make it seem like what? Tautology. So this is what you have. So when you use your own factorization method, I'm expecting you to get x equals to 3 or 3 also. So try it out if you have not done so that you can use that one to prepare yourself very well using factorization, and then you can see how solving using completing the square method and factorization on the same question will always result to the same answer. So that is what? Number 3. So you will do number 2. This number 2 has been solved by me under factorization. While I was solving questions under factorization, I actually solved this question. So if you have not seen the video, go and check the video I did under factorization. So the answer I got in that video using factorization method must be the same when you use completing the square method. So you have to use completing the square method to do this. You can see that the question is not really different from this format. So you should be able to do that. So I will be solving question number 5 now. Question number 5 using completing the square method. Right. I hope you are with me. Now, question number 5. I have 3x squared minus x equals to 2. Since I'm using completing the square method, my constant is already on this side. So I don't need to just send it here. But if you want to do it, write it first in the form of quadratic equation, no problem. But I already know that what? This is in the form of quadratic equation. Once I bring this my 2 here, it will be minus 2 equals to 0. Perhaps we should do it like that. So you can say 3x squared minus x minus 2 equals to 0. Yes, if you want to do it like this, no problem. Let's just give it this approach anyway. So I can now see that my A is 3. So because of that, I must divide all through by what? 3. So that my A will become 1. That will be 3x squared over 3 minus x over 3 minus 2 over 3 equals 0 over 3. And that will give me x squared. Let me bring out the number here. Minus 1 over 3x. Minus 1 over 3x is what will give me minus s over 3. Minus 2 over 3 then equals to 0. Then sending my constant to that side, I'm going to have 2 over 3. Now the coefficient of x here is minus 1 over 3. I will multiply it by half, square it, then add it to both sides. Okay, and that will result to minus 1 times 1. That will be minus 1 over 3 times 2. That will be 6. So this is the square of what I'm adding to both sides. Let's do that. So that will be x squared minus 1 over 3x plus minus 1 over 6 squared, okay, equals this side now, 2 over 3. What am I adding? The same thing, 1 over 6 minus 1 over 6 squared. So this can now be written directly now as x, what is inside there, minus 1 over 6 squared equals 2 over 3 plus minus 1 times minus 1 will give me 1. That's minus 1 squared. 6 squared will also give me 36. So that's what I will have. Then I can say that x minus 1 over 6 squared equals 2 over 3, or let's find the LCM, that is what? 36. That is 12 times 2 will give me 24 plus 1. And then that will give me 1 over 6 squared equals 25 over 36. Taking the root of square root of both sides, that will give me plus or minus root 25 over 36. That will give me x equals 1 over 6 plus or minus square root of 25 is 5, square root of 36 is 6, x equals 6, 1 plus or minus 5, okay? And that will be x equals to 1 plus 5 over 6 or 1 minus 5 over 6. X equals to 6 over 6 or minus 4 over 6. X equals to 1 or minus 2 over 3. Okay. I intentionally chose this question because this is the second question I gave you as an exercise under factorization. So you must have solved this using factorization method, and your answer must be the same with this using completing the square method. So the answer that you must have gotten in your factorization method solving this is x equals to 1 or minus 2 over 3, or in the order of minus 2 over 3 or 1. So anyhow you arrange it, but it must be the same with that. So I have also solved this number 4. Okay, this question number 4. I have solved it while teaching you solving quadratic equation using factorization method. So if you have not seen the video, please refer to the video. I've solved this using factorization method. So you also will try it using completing the square method, and it must be the same with the answer that I got in that video. So this is how you go about solving quadratic equation using completing the square method. I hope you have gained a lot in today's video. I plead with you to watch this video over and over again until you understand. If you have any questions, please pass that to me in the comment section. Share out this video, like this video, give me your comment, give me your thumbs up if you are coping very well learning with Mathemasoft, and try as much as possible to subscribe and turn on the notification bell. In the next class, I will be solving quadratic equations with the approach of quadratic formula. See you in that class. Bye for now.